Good morning, everyone. Welcome back once again for Doc GILMAC online tutorial. The topic we're going to discuss for today's tutorial is all about problems involving sets. Solving problems involving sets. Now, before discussing the topic for today's tutorial, let's have first a simple warm-up drills. Okay? So list all the possible elements of the given set's operations given set U is equal to 1, 2, 3 up to 10. Now, number 1, we have set A is equal to 1, 2, 3, set B is equal to 3, 4, 5. What are the elements of the union of A and B? Again, let's recall. When we talk about union of two sets A and B, it refers to the combination of the elements of the two sets. So we just combine all elements. So A union B is equal to 1, 2, 3, and 5. 3 is the common element for A and B, and this should only be written once. Okay, take note of that. Number 2, we have here set D is equal to 3, 7, 10. Set E is equal to 1, 3, 7, 9. What are the elements of D intersection E? Again, let's recall. When we talk about intersection, we only need the common elements for the two sets. So as you can see here, 3 and 7 are the common elements. So therefore, D intersection E is equal to 3 and 7. So take note of that. Now let's have number 3. Set A is equal to 1, 2, 3. What are the elements of the complement of A or A complement? Again, when we talk about the complement of A, we simply list down all elements of the universal set that are not in A. So we have 4, 5, up to 10. So take note of that. Now let's have number 4. Set E is equal to 1, 3, 7, 9, and set F is equal to 9. What are the elements of the difference of E and F, or E minus F? Again, when we talk about the difference of two sets, we simply list down all elements, okay, of set E that are not in set F. So E minus F here is just equal to 1, 3, and 7. Take note, 9 is common to both set E and set F, so 9 will not be listed as elements of E minus F. So take note of that. For number 5, consider the Venn diagram here. Given set U is 1 up to 10, set A is 1, 3, 5, 8, and set B is equal to 3, 5, 6, 8. Okay? Now consider the Venn diagram. So we have 1, 4, 5, 3, 8 for the elements of A, and then we have the elements of B to be 3, 6, and 8. Okay? Uh, and there are actually 4 elements outside the 2 given sets here. So what are the elements of A union B? We have 1, 3, 5, 6, 8. Again, just combine all elements of A and B. Okay? Now, how about the intersection of A and B? We have 3 and 8. As you can see here, these two elements are the common elements for both A and B. Now, how about A complement? A complement are the elements of universal set that are not in A. So we have 2, 6, 7, 9, 10. 1, 3, 4, 5, 8 are not included. About B complement. So 3, 6, and 8 are not included. So list down all elements of the universal set. So we have 1, 2, 4, 5, 7, 9, 10. Again, I repeat, 3, 6, and 8 is not included. How about A minus B? If you are to take a closer look on the given Venn diagram here, it's very clear. A minus B is just equal to 1, 4, and 5. Okay? Uh, that's it. Now, let's have an example on how to use Venn diagram in solving problems involving sets. Okay? Sometimes Venn diagram is actually used in survey problem. Okay, let's say this: a group of grade 7 LNHS students were asked if they enjoy mathematics subject or their science subject. The Venn diagram below summarizes the results. Okay, let's have the Venn diagram, two sets for the mathematics subject and S for the science subject. So we have here, okay, there are 15 who likes both math and science subject, 15 students. Okay, there are 40 students who likes mathematics only and 33 students who likes science only. And there are 12 students who dislikes both math and science. So that's how to read this. Now, how many students who likes mathematics subject? All in all, 40 plus 15, that's 55. How many students likes science subject? All in all, we have 33 plus 15, that's 48 students. So that's how to read the given Venn diagram. Let's have again number 2 illustration. A group of students were asked what pet they had at home. The results are summarized in the following Venn diagram. So we actually have dogs and cats here. Okay. So, so as you can see, there are 18 students who have actually pet at their home. Okay, that are dogs and cats. How many students who have dogs only as their pet? There are 50 students. How many students who have cats only at their home? Okay, there are 22 students. Now, how many do not have any pets at all at their home? There are 10. So that's how to read this Venn diagram. How many students all in all have dogs at their home? 50 plus 18, 68. How many students who have cats at their home all in all? 22 plus 18. That's 40. Okay, so that's how to read the Venn diagram. Okay? Now, let's have an illustrative example on how to use Venn diagram in solving problems involving sets. Okay? Now, let's have this number 1 problem. Out of 50 students, 16 are taking up boxing trainings, 25 are training in karate, and 8 are training up both boxing lessons and karate training. How many students are taking boxing trainings only? How many are taking karate trainings only? How many students are neither taking up boxing and karate? Okay, the first thing we have to bear in mind in drawing a Venn diagram is simply the intersection of the two sets, boxing and karate. So there are 8 students taking up both boxing and karate, 16 taking up boxing trainings, and 25 taking karate. So let's have the Venn diagram here. So let's draw a Venn diagram, rectangle, then 2 circles here for set B as boxing and set A as karate trainings. Okay, so here's how to draw. Yes, write first the intersection of the two sets, 8, and then there are 16 who actually train boxing, so 8 plus 8, we have 16. So that's, from here you write 8, okay? And then for karate, there are actually 25, so 8 plus 17 is 25. Okay, and then 17 plus 8, that's 25 plus 8, 33. Out of 50 students, there are 17 who don't actually train neither boxing nor karate. Okay, so from here, we were able to answer the questions in the given problem. Okay, and of B here is equal to 8, as you can see here. N of K is equal to 17. And there are 17 who don't actually train boxing and karate. Okay? So, let's have illustrative example number 2. In a group of 100 customers of Green Cub's Pizza, 80 of them ordered mushrooms on their pizza and 72 of them ordered pepperoni. 60 customers ordered both mushrooms and pepperoni on their pizza. How many customers ordered mushrooms only? How many customers ordered pepperoni only? How many customers ordered neither mushrooms and pepperoni? Okay, now let's have the Venn diagram. Again, I repeat, the first thing you have to bear in mind in listing all elements in the Venn diagram is the intersection of the two sets. Okay, so take note of that. Let's have the Venn diagram for the two sets, mushroom and pepperoni pizza. Okay, there are 60 who ordered mushroom, both mushroom and pepperoni. There are 80 who ordered mushroom, so 60 plus 20 is 80. Take note of that. Then, for pepperoni, there are 72. 60 plus 12 is 72. 72 plus 20, that's 92. So, out of 100, there are 8 customers who don't neither mushroom nor pepperoni. Okay? So, from here, we were able again to answer the questions given in the problem. Number of customers who ordered mushrooms only, there are 20. So you can see here. Number of customers who ordered ordered pepperoni only, there are 12. And the number of customers who did not order neither pepperoni and mushroom are 8 customers. So that's how to use the Venn diagram in solving the problems involving sets. Now let's have number 3, illustrative example. 85 students were asked about the subjects they like to study. 35 students like math, 37 like history, 26 like physics, 20 like math and history, 14 like math and physics, 3 like history and physics, 2 students like all the 3 subjects. Now, the questions are how many of these students like math only, physics only, history only? How many of these students didn't like any of the 3 subjects? How many of these students like math and history, but not physics? So, again, I need to emphasize once again in drawing a Venn diagram, always bear in mind the intersection of the sets. So since we have 3 sets here, the intersection of the 3 sets are actually 2 students, like all 3 subjects. Okay? Let's draw a Venn diagram here for the 3 sets, math, history, and physics. Okay, so where will you locate 2 students here? So actually in this middle. Okay, this is actually the intersection of the 3 sets. So as you can see here, so we have here 2. Okay, so this one. Okay. Now, next one, the intersection of math and history. So there are 20 who likes both math and history. So 2 plus 18 is 20. Okay. So that's how to do it. Now, there are 14 who likes math and physics. So 2 plus 12 is 14. Now, there are 3 students who like physics and history. So 2 plus 1 is 3. Okay? Then there are 35 students who like math. 18 plus 2, 30, 20 rather, plus 12, 32 plus 3, 35. Okay? Then, there are actually 18 plus 2, 20, 23, 21, okay? 37 students who like history, okay? Then, physics, we have 14, 15 plus 11, 26 students who likes physics. Now, out of 85, there are actually 22 students who don't like the three subjects. Okay? So from here, we were able once again to answer the questions in the given problem. How many of these students like math only? So there are 3. How many students like physics only? There are 11. How many students who like history only? There are 16. So that's how to use the Venn diagram. Okay? So we have here the given answers. Next one. So again, we consider the Venn diagram and the questions given for letter B. How many of these students did not like any of the 3 subjects? So as you can see, there are 22. Okay? Next one. How many likes math and history but not physics? Okay. Uh, so we have here the question. As you can see here, there are 18 students who likes both math and history. And 2, okay, actually does not like math and history. Okay, so we were able to answer the questions given in this particular problem. Okay, so take note of that, how to use the Venn diagram in solving problems involving sets. Again, I would like to thank you once again for watching and stand by for my next tutorial. This is Doc GILMAC. Once again, stay safe and may God bless us all.